we're ready. Donna, go ahead. Any question? Let's start.
I'm just looking through the stuff that we were going through.
Anyone else till Donna finds a question? Anyone else has any questions for me? Anything?
I'd like to review on the review guide, there was a question for finding marginal profit. There was ln is the function, so I'd just like to review that.
Yeah. Do you have a function for us? Awesome. Perfect.
We could just do the one on the review guide. Okay.
I don't remember what it was.
2x minus 0.3x ln x.
Perfect. So in order to find the marginal profit, as we know, the marginal profit is a function, and it's basically the derivative, the rate of change of this function. Derivative or rate of change. So in order to differentiate this, we have p prime of x equals, this is just 2, but here I have to be very careful, because this is a product. So I have to use the product rule. And I don't like...
Okay, that's where I was getting confused.
The first function prime is 1 times natural log x plus the first function times natural log x prime, which is 1 over x. So x with x will go away, so this equals 2 minus 0.3 natural log x minus 0.3, because this is 1. 2 minus 0.3 is 1.7 minus 0.3 natural log x. This is the marginal profit.
Thank you.
My pleasure. Other questions? Donna, did you find your other question?
I'm good on the other one because it's just like the one we did right before class started.
Okay.
So I'm good. I'm good there.
Good. Other questions for me? Anyone? Anything? Any?
Can we do one of the ones where you do the square root, use the differential to approximate a square root?
Yes. So let's say a square root of 99. Do you have an example? Maybe you don't want this one. If you have an example, let's use yours.
I don't. I'm not sure if you did 99 last class though. Sorry.
I know I didn't. I mean, I think I didn't. I shouldn't be very confident like that. I don't remember doing 99. So this is approximately f of x plus f prime of x dx. So this is the formula right away. I have to identify 3 different things. I have to identify the function, I have to find x, and I have to find dx. And of course, after that, I have to find f prime of x. So at this point, I will look here and identify these 3 pieces. Once I identify them, I put them in here, and it's done. I don't have to do anything else. So can anyone give us the function?
Is it square root of x?
Of course, nothing else. So this is 1 over 2, the square root of x. Good. What about x? What do you think? What would you have preferred to have here? And don't say 25, because 25 is so far away from 99 that we don't even talk about it. And don't say 36, because again, 36 is so far away from 99, it's not possible. What would you have liked to have here?
81?
Very far away from 99. 81 is perfect, but too far away. Huge. Infinitely many numbers between.
Can you go up 1 to 100?
That's it. What about dx then? If x is 100, what is dx?
Negative
Exactly. That's all you have to do. That's it. So f of x will be f of 100, which is 10. F prime of, go ahead. F prime of x will be, the square root of 100 is 10, times 2 is 20. So this piece will be 1 over 20. And this piece is negative 1. We're done. So the square root of 99 is approximately 10 minus 1 over 20. So this is 200 minus 1, 199 over 20. So when I share my screen and go to the calculator, you should always check. Mistakes always occur, potentially. So then I have the square root of 99, and I will enter 199 over 20. It should be super close. So it's 0.01. Sorry, I'm muting everybody. So please unmute yourselves when you want to speak. Perfect question. Anything else? Anything else that you can think of? Anything else you want to talk about or work on?
Can you go back real quick? You lost me at after x equals 100. I just think I have too many things in my head right now.
So the question is, why is x 100?
You lost me after x equals 100.
But how do I get, if I get x equals 100, how do I get 99?
Oh, minus 1, okay.
Is that better? Because remember the formula, I didn't write it here, but this is f of x plus a little bit. But the little bit could be negative. So this side is f of x plus a little bit. So if x is 100, the little bit must be negative 1 in order to still obtain 99. I cannot change this. This is carved in stone. So if my x is 100, my dx has to be negative 1 because 100 minus 1 will give us 99. All these are good, but so far away that we cannot even talk about them. Remember, dx has to be tiny. Tiny. If I consider 81, dx is 18. 18 is not tiny. 1 or negative 1 is almost tiny. I wouldn't even consider negative 1 being tiny. But it's close. Good. Perfect. Other questions? Anything else? Are we okay for the test then? Anything else? Okay, I can always stop if you have any questions. I will continue today. We'll continue today with chapter 4. I will not tell you the title because we are far away from discussing that particular title. So this is my page 2. We start chapter 4. We're going to start with 4.1, something called antiderivative. We have so many words that have derivative in them, differentiation in them, or differential, etc., etc. So, give me a function. I just want to establish something very important. Just give me a function, please. Any function you can think of.
3x squared plus 6x plus 9.
Now, we're going to talk about two different things. Derivative and differential. And we know they're not the same. Can anyone give us a derivative of this function?
for 6.
Excellent. Can anyone give us the differential of this function? How do I write it? What is the formula? And how do I write it? Which is not the derivative. Anyone remembers the formula for the differential? Anyone, please? Well, we discussed this, and it's part of the test tomorrow. So can anyone give us the formula for the differential of a function? Please. Anyone, please? Is anyone with me? Okay.
Would be 6x plus 6.
Differential of the function. Very important. I need it now for this. I need the differential of a function. What is the formula?
Is it f of x plus
No, that's a value. That's a value, that's algebra.
Would it be dy over dx times 3x squared plus 6x plus 9?
No. So first of all, what is the notation for the differential? For the derivative, we know it's this. But what is the notation for the differential of a function?
dy?
Exactly. Stop. Perfect. Excellent. This is the differential. Good. Now let's continue with the formula. Awesome. For any function, leave this function alone. I just want to write the formula first.
That
dy
derivative.
over dx.
But I have dy on the left.
dy by dx.
No. So dy has a formula.
Derivative.
F prime of x times dx. Please remember this is extremely important for chapter 4. So dy equals f prime of x dx. Now can anyone give us dy for this function? So this is the formula. Now what about, how do I write the dy for this function?
Times.
You mean plus 6, right?
Mm-hmm.
Maybe you said it, I didn't hear it. In parentheses, times
Dx.
that's it. And you can say, what's the big deal? Okay, well, this is the times dx and this isn't. It's a big deal, and you'll see why. So when we talk about the derivative, we simply look at the derivative of this function, which is the rate of change of this function at any point where the function is differentiable. But when we talk about the differential of the same function, this is crucial. The notation is no longer f prime, it has to be dy, and it has to have f prime, the same thing, but multiplied by dx. Awesome. Now stay with me, please. This is very important, but I'll get back to it. So this was just a refresher. Good. What is the antiderivative? What does it mean? So remember, we were given the function, and this, let's say, is the distance. And if we asked, let's find f prime, what did we find? when we differentiate the distance, what do we get? What is it?
Reduction.
Velocity. When we differentiate the velocity, what do we get?
Acceleration.
Very good. Awesome. So this is possible when I'm given the distance. Now, let's suppose, given the velocity, find the distance. In other words, going backwards if you want. How can I be given the velocity? Yes, the velocity is a function. What if somehow somebody determines the function that gives the rate of change of aspirin in the bloodstream? The rate of change of aspirin in the bloodstream, and now I want to determine the function that gives the rate of that gives something related to the aspirin in the bloodstream, not the derivative. So I may be given the velocity function. Somebody determines the velocity function and asks us, okay, now find the distance function. So going backwards. Okay, how do we do that? Good. So we start with a couple of formulas. So if I have a constant c, when I differentiate the constant, I get 0. So please remember that. So when I have x, when I differentiate x, I get 1. What if I have x squared? When I have x squared, when I differentiate x squared, we know that we get 2x. One more. If I get x cubed and I differentiate, I get 3x squared. But now how do I go back? What if I'm given x to the nth power? What will that be to go back? Well, it will be x to n plus first over n plus first prime to go back. So if I am given, let's say, find the antiderivative. This is the antiderivative. The antiderivative of x to the fourth. Using this formula, I will say x to the fifth over 5. This is the antiderivative, of course. I will say plus a constant c. Don't discuss that just a moment. In a moment, we'll go back to it. So I have x to the fourth. That's the velocity. I want to determine the distance. I want to determine the function that I differentiate to get the velocity. The function that I differentiate to get this. What is it? I bring down 5, simplify, and I get x to the fourth. Now I'm saying something here. I'm saying that this is not the only function whose derivative is x to the fourth. There are many functions whose derivative is simply x to the fourth. Why? Because I can add a constant, any real number. When I differentiate this, it's guaranteed to get this, because c prime is 0. So let's do this one more time. When I differentiate this function with any constant, I can have 1, -3, -1,000, 5,000, whatever constant you want, because all these, when I differentiate them, I get 0. So x to the fifth will be prime, will be 5x to the fourth. I simplify the 5 and I get x to the fourth, because c prime is 0. So we call this the most general antiderivative of this function. The most general antiderivative of x to the fourth. the most general antiderivative of x to the fourth.